In between managing a team at Up and Ferocia, and running a bank, as you do, and parenting 2 children, he finds time to play Mario Kart, which is relevant to the next talk. We're going to have some people up on stage soon who are going to play Mario Kart, which is cool, at a conference. We're just going to watch them play games all day. And Michael's just going to stand there. No. So this taps into your enthusiasm for the game, would you say?
Sure, yeah. Yeah, I mean, this is, well, I'll just get into it. This is a story that was born out of banking. I work for a serious company that builds serious banking software in a serious industry. In case you hadn't gathered, it's all very, very serious. So naturally, what do? When we're looking to relax is we play Mario Kart, and we take that pretty seriously. You can tell here that it's serious because, sorry Chendo, it's not the most flattering photo, but you've got your tongue out. I think Dan Werner is kind of leaning into the corner, and you can see that everybody is sitting probably about 3 or 4 feet from a ginormous television, taking it pretty seriously. You know you're taking Mario Kart seriously when you start looking at the world a little differently. But as software developers, it started with a question. The question being, who is the best at Mario Kart? Who is it? And naturally, as software developers, we software all the things. So we're like, well, we can solve this with software. So we did. We built a little leaderboard application, and it kind of looked like this. And I could have taken any race results here, but let's pick one that's flattering. And it's a Slack integration with a sort of pretty standard Rails app. You go Kart result, Mike, Langers, Werner, Juzzy. And the application, so the Rails app, will post back to Slack with here's the current leaderboard, and here's who moved up in the rankings and all that sort of stuff. If you notice, there's a score column there. Well, actually, usually this would sort of elicit some sort of response like this. But if you notice there's a score column there. So we needed some mechanism to track this leaderboard. And we started out with ELO, actually, which is an algorithm based off chess. This, incidentally, is a picture of Juzzy. Where is Juzzy? Over there. Yeah, this is Juzzy's head after he's lost a game of Mario Kart. That's actually, that's why I chose that photo. But we started off with the ELO algorithm. So ELO is an algorithm that's used for tracking chess games, tennis, all that sort of stuff, but it works with 2 people. You've got a winner and a loser, and you track those sort of games over time, and it can predict, given 2 people, what's the likelihood of player A beating player B. The problem that we had in Mario Kart is actually we have 4 people in a game, so to sort of solve this was we would enter this as a series of 2-player games. So with that result of Mike, Langers, Werner, Juzzy, we would enter Mike beats Langers, Mike beats Werner, Mike beats Juzzy, and so on and so forth. Sorry, Juzzy. Nobody. Anyway, brutal. And that was okay, except it came up with sort of one person, I'm the king, yes. So clearly that algorithm wasn't doing very, very, very good. So we stumbled across this algorithm called True Skills. So this is, there's Ruby bindings for it, or sorry, a Ruby implementation of it, but it came out of Microsoft Research as part of their work on Halo 2. And it's for tracking sort of arbitrary numbers of players, arbitrary numbers of teams, and all that sort of stuff. And so Tom Meyer, one of the developers I work with, went out of his way and implemented this. And after Tom Meyer implements this, Tom Meyer agrees wholeheartedly that his new algorithm is better. So we proceeded with that. Now, it wasn't enough to simply go, well, okay, you're the top of the leaderboard. It's actually, you want to know how much better am I than an individual player. So we added this functionality next, which was the ability to sort of cut, inspect an individual player, and it would go, this player has beaten you a certain amount of times. And I think it's some sort of bug or something that it says, Juzzy's beaten me 86 more times. I think that's an issue, and we're looking into that at the moment. But That wasn't enough. We needed to go, okay, we know how much an individual player has beaten another one, but we actually wanted to sort of plot the decline of a player over time. So we added this functionality. So basically, the way this works is it would respond with, you know, the Google chart image drawing API. The Rails app would sort of generate a chart and respond with like a Google image URL, which would then get inlined in Slack, and you can sort of query it to go, okay, chart any of these players over any of this date range. And we ended up with that. And look, that's, I mean, you might say that's getting a bit ridiculous, and it probably is. And that's out actually as far as you could probably reasonably take this without doing sort of, I don't know, something stupid like parsing the video input of the switch. And yeah, so that's exactly what we did next. So let's demo it here today. So Juzzy, you can come up. We actually need a few people who can play Mario Kart. So does anyone here own a Switch? Yep. Yeah, do you want to come up? And yep, up you come. And Pat. Yes, absolutely keen for it. So we've got a Switch set up here with 4 players. And what I've got is a little bit of a hack to theoretically get the video input. Hey. And let's just... So this is our system, Kartistics. So we've got here, this is actually what the guys are seeing there. That's Mario Kart running on a Nintendo Switch. Pat, you'll be fine. You don't need the controls. You got this. So Juzzy's going to kick off a race here. This is 4-player, 150 cc's. That'll be great. You can see our system on the left. So well, we'll just let them go. We'll see how it goes. Great course. My favourite track. So what's happened here is our system's, detected that we've got a match in progress. So we can click into that. Mario Kart seriously at work. So, how does this work? Well, it's all it works with a lot of Ruby. A lot of Ruby. Is that you? Yes, that's good. That's good. Is that you in fourth, Pat? Yeah, you're allowed back on the plane. Is that you in fourth, Pat? Okay, 11. No judgment. No, you did great. Perfect. Thank you to our competitors. So what's going to come in here? So I don't know if you can sort of see that, but you get split timings as well. So we can track. So that took 166 seconds. Player 3 was 3 seconds behind. Player 2 was 8 seconds behind. Player 4 was 15 seconds. So a fair bit going on. But yeah, so it does matches over time and all that sort of stuff. What a finish match looks like. Again, I could have picked any match, but you get like your name up there, and you get this sweet little crown and all the races and all that sort of stuff. So yeah, Mario Kart. Who would have thunk it? So, what just happened? Well, how this all works is it's broken. The solution's kind of. You guys can probably go sit down. Thank you. So the solution's broken down into 3 steps, right? First step, we need to get an image off that Nintendo Switch. Second step, we need to work out what the hell's going on in that image. And third step is we kind of need to reconstitute this state of a game and a match and all this sort of stuff from those little fragments of information. So I'm going to break down how that all works so that you can build your own. So getting an image off a Nintendo Switch. How do you do it? Well, yeah. My initial solution was this. Nintendo Switch, HDMI splitter, something Ruby, and a TV. And then I stumbled across these things, what these are, HDMI to Ethernet senders and receivers. And typically, they're for when you want to do things like this. So you would buy a transmitter and a receiver. You can have 100 meters of Ethernet cable and then another HDMI display at the other end. But what I wanted to do was kind of something like this, like chuck a computer at the other end of that rather than a HDMI receiver. If this is sending network traffic, well, we can figure out what that traffic is, and hopefully we can get some imagery. So basically, what I did was fire up TCP dump. So sudo TCP dump. Yep, bigger. And you can see here that this thing is absolutely blasting out UDP traffic. So sweet, okay. With a little bit of FFmpeg foo. And what that does is basically grabs this UDP stream at 2 frames a second. It writes it out to a bunch of files that look like this. So you've got 01, 02, 03, etc., etc. And this will just keep dumping them until you've run out of disk space. So now my solution kind of looked like this. I had a HDMI splitter going into a HDMI to Ethernet converter thingamajig into a Raspberry Pi running our sweet Ruby. I was done. Nailed it. And this was me when I sort of had that working, that FFmpeg command. It took a little bit of time, more than I'd like to admit. So step 2, extracting the information from the image. Now, I could have reached into machine learning, but I hadn't seen Paulo's talk from tomorrow because that hasn't happened yet. So I didn't know how to do that. So what I did was I wrote some Ruby that kind of looked like this. Here are all the screens that I was interested in, and I needed to implement 2 methods. I needed to implement, okay, firstly, for this given image that I'm looking at, does this image match the main menu screen? And secondly, if it does match the main menu screen, how do I extract the data out of the screen? That's like the core logic of how we get the information out of the images. So looking at the main menu screen of Mario Kart, what I needed to find was something that is on this screen that is unique to this screen. I could have picked anything. There's actually lots of good candidates on this screen. It was not too bad. So I went with this wireless text there. That's not used anywhere else in the game. It's not presented in that size. So the logic I sort of went with was this. Screen grab equals reference image, and that does not work. Oh, I got this close. And I came across this thing called Fashion, which is, again, Ruby bindings around the phash library. Has anyone here used phash before? Yep, one person. A couple of people. Great. It is awesome. It's for detecting duplicate and near duplicate imagery. So if we have a photo of a koala, that'll be the phash of that photo of a koala. And let's say we make it grayscale. The distance in bits between the first one and the second one is only 2 bits, because they're quite similar imagery. And let's suppose we crop the image a bit and we change the saturation and that sort of stuff. The distance in bits between those 2 hashes is only 14 bits. Whereas if we take a completely different koala, the distance is quite large. It's 28 bits. So for detecting our wireless screen, something like this, it worked perfectly. Hey! So our main menu detection code looks like this, and this is all Ruby. Basically, grab a crop of our screenshot, absolutely nuke the thresholds to eliminate as much non-essential information as possible, convert it to a phash, and compare that phash with the reference image. If it's less than 10, you're looking at the main menu. And that worked. So thank goodness. So I had a strat to get information out of these images. So a race screen, there's a heck of a lot going on here. And the questions that we want to answer is this a race screen, yes or no? What position is the player currently in? Has the player finished? And what items does the player currently have? So detecting whether or not this is a race screen, this is a super simple approach, but you get this black, or as I found out, almost black bar running down the center of the screen, and simply just grabbing a pixel off the top of the screen and going, sweet, is this black? Boom, race screen detection, done. Yeah. The problem was it was picking up this was a race screen, so I had a bit more work to do. So something like this, so you check a pixel at the top, you check a pixel at the bottom, but then you also check a pixel at the top left and bottom left that they're not black, and that a bit more reliably detected race screens in Mario Kart 8. So we needed to work out player positions as well, and I'll turn this one up if we don't have it. Yep, there we go. So I want to grab that little fragment there. This is kind of, oh, whoops, I actually have Mario Kart going on in the background still. Ha! Let's shut that off. There we go, nailed it. Okay, the problem is that the images in Mario Kart kind of do this. You see a little animation going on in the background, and this is actually Chendo having a terrible time at the end of a race of Mario Kart. About now you hear the no! Hot garbage. Yeah, love the little sad Yoshi noise at the end. But yeah, there's a lot of variance in that. The solution to solve it, again, it wasn't anything super fancy. I just had a heck of a lot of reference images, really. And I compared it against all of those. So there was some on dark background, some on light background. If it matched a certain threshold, I'd say you were in position 3. And that was pretty good. Secondly, was working out whether or not the player was finished or not. So I took a big sort of slab at the center of the screen, and that worked terribly. Just because you get a lot of background noise in there that's actually non-essential. So just taking that little part of the F, it doesn't need to be human readable, that worked much better. If those pixels are there, then in that particular frame, the player has finished. Finally, for item detection, again, it's a pretty similar strat. Take a crop of the box that shows the player's current item and compare that with a known reference image. So you would end up with like a slug of data that would look like this. In this particular instance, the player in position 5 has a green shell. The player in position, player 3 has just finished the race. How am I going for time? Love it. If anyone's interested as well, I've read a lot about Mario Kart. Yeah, as you can probably tell, yeah, I do work, I swear. The item distribution in Mario Kart is fascinating how it works. It doesn't actually work. So if you're in position 2, the items that you receive is determined by your distance from the first player rather than your position. So there's forums and forums of Mario Kart information. But basically, if you get screwed over by the person in second because they have, I don't know, 3 red shells or some shenaniganry in their item selection, think of it as a compliment that you have established such a lead over that person that they could obtain those items. But it has this neat effect of continuously, I guess, compressing the field. The further back you are, the better the items you get, and that's, I guess, what makes the game fun. So on to the race results screen. So you need to know this screen because, well, we need players' points and we need to know who to put the little crown on at the end of the game. So we want this screen. So the end of a game of Mario Kart kind of looks like this. You come flying, finish, finish, finish. You see this screen that we want. We don't want this screen. So that again, unfortunately, you get frames like this. We're sampling at 2 frames a second, and if this just falls on the 500 milliseconds that we're sampling, you'll get a screen like that. So you kind of have to deal with that from a software perspective. The other problem you get is, yeah, so we want that screen. We don't want that screen. Want the first one? Not the second. They're almost identical. So looking at this screen, or that one, basically what we can do, well, the solution I came up with, was take a very, very skinny crop of this section here, and you can do the math and work out, okay, if we take a 144 pixel crop, and I chose 144 pixel because it is neatly divisible by the 12 players, and then go, okay, position 1, so that offset 1, if we've got 12 red pixels or thereabout in that first offset, then we can say with a high level of confidence that the red player has finished in the first position. So that actually worked really, really well, and that's what I'm using in the code that was running. So that's race result screens, and of course that ignores these bits where there's like blue arrows and green bits and all that sort of stuff. So we have race screens, we have race result screens. There was also intro screens. The part that sucked about this was that there's 48 of them, so I needed to obtain imagery for 48 intro screens in Mario Kart. And basically you take a crop of the name down the bottom, compare it to a known reference image, and it is all good. So at that point, we are done. We can reliably, using Ruby, extract the information that is going on from a given frame of Mario Kart 8 Deluxe on the Nintendo Switch. Finally, and this is probably a lot more similar to sort of the stuff you do every day, is we need to reconstitute this concept of a game and a race from all these little fragments of information. So basically you end up with an event stream that looks like this. Main menu, loading screen, intro screen, blah, 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 blah. I went with a data model that looked like this. You have a match. A match has many races. A race has many, good catch. A race has many race snapshots. And then you have a state, so it's kind of like a state machine, which has a current match and a current race. And then if you see an event like the main menu come in, you simply nuke the current race, you nuke the current match, set both of those to nil. You see a loading screen, it means you must be in a match. So you need to create one, but you certainly can't be in a race, so you set the race to nil. You see an intro screen, basically create a race if you don't already have one. You see a race screen. We just write hundreds and hundreds of those race snapshots whenever we get them, and they're the things that we sort of plot over time in that chart I was demoing. And then the race results screen, you set the race status to finish, and you set the final positions of the players. And you're going to see 6 of those. So we play a fairly strict Mario Kart setup where everybody has to be the same player, so there can be no advantages and no crying of foul play when, I don't know, Tom wins as Morton. So everybody has to be Yoshi, set of 6, random course selection at 200cc. And we'll get 6 of those come through. And then at the end of it, you'll see a match results screen, which is sort of slightly different to that race results screen, and you set the current match to finish. Nailed it. So what did I learn? Well, I learned a lot building all of this. I guess the first being that no matter how much Mario Kart you play, the game finds new and interesting ways to stuff you over. I guess as a Ruby developer for years I've been working with Rails, and it's quite easy to box the language into just handling web apps. But making this, for me, reaffirmed all the great problems that you can solve with Ruby. I hope that by sharing this story that I might motivate some of you to go out and apply Ruby to new and interesting problems. I genuinely believe that as a Ruby developer, yes, it might not be the fastest language, but you can make anything. You can make a Mario Kart streaming setup, and it's all pretty straightforward to do so. Additionally, everything I've demoed today would simply not be possible without the vibrant open source community that we have. Whether it's something we all take for granted, like simply being able to store my race snapshots in Postgres, to just being able to have Ruby bindings for phash ready to go, or the Ruby implementation of the TrueSkills algorithm. So in that tradition, I'd like to share this frame analyzer that I built for Mario Kart, which is open source. You can go check it out. The code written is pretty quick and dirty. I've got 2 kids and I'm launching a bank. But I hope that can be useful for some of you, and yeah, PR's welcome. Finally, a massive thank you to my work up. They paid for me to be here today, supported my Mario Kart addiction, that allowed me to in turn support the open source community. As well as playing Mario Kart, we're building Australia's first digital bank using Ruby, with the stated goal of helping people spend wisely and save effortlessly. If you, like me, have ever wished for a bank that could help use your money better, consider signing up by downloading the app and using the promo code Ruby18. Lastly, a huge thanks to the RubyConf organisers, especially Mel, for handling my fiddly AV requirements. No, it was absolutely fantastic, and I really appreciate the opportunity to speak today. Thank you very much. Yep. I've got time for some questions.
Yes, this time.
Yeah, sweet. So if anybody has any questions on any of the things that I've demoed, yeah, please. Oh, yeah, look, so I had to do it. So I sort of busted this all out at demo one Friday. So I had to do the whole thing, I guess, kind of stealth mode. And look, more than I'd like to admit. But yeah, I guess it probably took maybe evenings for 2 weeks, perhaps, most evenings for 2 weeks to get a lot of it going. And then when I was able to demo it at work, a bunch of people jumped in, like Chendo built the item detection, Levi improved the charting that we have, and the designer that we have, who's the king, he improved some of the styling of it, so yeah. Yep.
So now that you've done all the hard work, if I am keen to implement this in my workplace, how much effort will that take?
Yeah, well, you need to buy this, basically. There's like a box of stuff here, but you need a HDMI splitter, some device, whether it be a Raspberry Pi or something like that, one of these HDMI to Ethernet dongles, and yeah, run up the code. But it's all pretty straightforward. The code's there. The way I built it, because I didn't have a lot of this kit straight off, was to actually take screenshots on the switch, and then so I could write a lot of the Ruby code, prove the thing was going to work prior to organising the HDMI to Ethernet thingo. But yeah. Yep. Yeah. So it takes about 190 milliseconds to do a frame. So if I had, and then it's got to send it to a server. So it's actually, the server's running in Melbourne at the moment. So I'm kind of shocked that it was able to do all that. What could go wrong? With better kit, you could increase the sample rate, which would give you sort of more resolution in the race snapshots. Yep.
Thanks. Any plans to implement support for the battle modes?
Battle modes. Well, we don't play that, but PR's welcome. We've got a very, very strict. So we actually have like it's called the IKK. Set up at work that regulates any changes to the format of the game that we play. So, yeah, it's currently not for discussion that we'd implement battle modes. Yeah.
How do you deal with disk space?
Yeah, so basically in that loop that I ran, the last step of the loop is sort of in an ensure block to just delete the image. I have had it just completely fill up the disk, and I'm like, but yeah, it just passes the image, grabs the data, forwards it out, deletes the shot on disk.
I think we've got some questions over here.
Yep.
There were a lot of features you implemented that the solution to how to detect something in an image was quite non-obvious. Are there any problems you haven't figured out a solution yet, or features you'd like to implement but you wouldn't know how?
Look, I hate to say, but this is probably as far as I'll take it. So what I want to do, if I had more time and wasn't also shipping a bank, I would get it to record the races, but I also want to set up a webcam facing the players to record the reactions, overload those in a GIF, post it to Slack, and immortalize those forever, because I think they'd be quite entertaining. Yeah. Yep. Well, at the moment, Tom is currently top of the leaderboard. I'm not too upset about that. A little upset. I'm sitting in third, which is okay, I guess. Yeah, so it's actually pretty depressing because I'm not sure how much I should share, but I practiced a little bit at home, and I still could only get to third. So I've got the switch here if anyone wants to take on, I don't know, Juzzy or Chendo or myself or anyone who plays a bit. Yeah, certainly welcome. Yep.
Just a real quick one. Does the IKK have any stipulations in place if you've got less than 4 players? And
yeah.
Does it support it? Yeah.
So 3-player games will work. Yeah, 3 or 4 player. It needs the black bar down the center of the screen. Else the image detection doesn't work. Yeah. Any more for any more? Cool. Ship it.
Thank you, Michael.